Hello everyone, Aaron here, and welcome back to Leetcode. Today we are doing the My Calendar 3 problem. A K booking happens when K events have some non-empty intersection, i.e. there is some time that is common to all K events. You were given some events, start, end, which is an open-closed interval. After each given event, return integer K, representing the maximum K booking between all the previous events. Implement the myCalendar3 class, initializer, and bookings. So for example, here we create it and then we add a 10 to 20 booking. So that means from 10 through to 19 inclusive, or 10 through 20 exclusive. We have a booking from 50 through 60. That doesn't overlap, so both of those return a 1. But 10 to 40, that does overlap with something. It overlaps this guy. There's something there with a 2 booking in it. 5 to 15 also overlaps. That's a 3. 5 to 10. That doesn't overlap here, it does overlap there, so that's only a 2 overlapping when adding that event, but the largest is still 3. 25 to 55. That lives in this window from 10 to 40, but the 3 overlap happened from 10 to 15, so it does not cause an increase in the amount of overlap. Alright, I'm going to be quite brutally honest, this seems extremely difficult. We could just store all the events and compute the overlaps each time. That's horribly inefficient. What I'm inclined to do is store the non-overlapping segments somehow. So store 10 to 20, store 50 to 60. And then store 10 to 40, but store it as 10 to 20, 20 to 40. So split this because it overlaps with this range. Because then we know in the 10 to 20 range, there's a stack of 2. But then in the 20 to 40 range, it's only 1, and then in the 50 to 60 range, it's still only 1. Yes. That sounds correct. And then the 5 to 15, we see it overlaps with our 10 to 20 range. So we've split that into a 5 to 10, a 10 to 15, a 15 to 20. Yes. Yes, I think that works. And then in that one that we call the overlap, we increment its overlappingness. Okay. I think I have a rough idea. The way I want to store this, I think, is going to be a kind of tree structure. And we're going to keep track of the max overlap we've seen so far. And then in book, what we want to do is if self.interval tree is none, self.interval tree is equal to I interval tree with start, and let's call this IV node start end 1 self.max overlap equals 1, return 1, else, whoops, that doesn't need a semicolon. Let me just quickly create that IV node. So we're going to keep a left and right as well. And the idea is that if we look at this interval, if the thing we're inserting is before the start, then we're just going to create a new node on the left. Otherwise, we're going to create a new node on the right. So, whoops, hands in the right place. Cur is self.interval tree. If end is less than cur.start, go left. In fact, hang on, no. While true, because this is going to have to iterate a bit. Elif start is greater than or equal to cur.end. This is our go right situation. I'm just going to pass these for now. Else overlap. So if we go left, what we want to do is if cur.left is none, cur.left is equal to an IV node start end 1 self dot. Oh, in fact, what we'll do here is we'll just break out. In fact, I'll call it overlap. We'll record the overlap when we break out. In fact, we'll set it to 0 to begin with. Self.max overlap is the max of self.max overlap and overlap. Return self.max overlap. And the overlap equals 1, else cur is equal to cur.left. Then we want similar logic down here. If cur.right is none, cur.right is IV node start end 1 overlap equals 1 break, else cur is cur.right. And now we're at the tricky point. There is overlap between these nodes. So the cases are, there's 4 cases as far as I can see it. Ooh, yeah, there's 4 cases. If cur dot if start is less than cur dot start and end is greater than or equal to current.end, the new completely contains the old. Elif start is less than car.start and end is less than car.end. Overlaps on the start on the left. So this is basically, if I draw a little window here, this is sort of the new overlaps with the old, like this kind of interval. Here we have something that overlaps like this. How can I interface with this? I'm just trying to think of a good way to draw this picture, because that's not what I want at all. So if that's what we've got here, this is what this one looks like. The new one overlaps on the left. Elif start is greater than or equal to current.start and end is greater than or equal to current.end. Overlaps on the right. So this is where we have the start, and then they start to overlap, but then this thing ends and it continues on. Else, so this one is old completely contains new. What we want to do, this one looks like a this particular case. So we need to handle each of these cases. Let's start with new completely contains the old. So the idea here, in fact, no, let's go the other way. Let's start with old completely contains the new. So this is start is greater than or equal to current.start and end is less than current.end. So what we want to do is we basically want to break up our current, if the old completely contains the new, what is it we want to do? I've got myself confused. We basically want to break it into 3 chunks. 1, 2, 3 chunks like that. Got the old thing here, the start and the end. We know that's a non-overlapping segment. So what we want to do is new left is IV node of cur.start start. And this is car.overlap, because this part doesn't have any new overlap with it. New right is an IV node of end car.end car.overlap. So that's this chunk. And then it's going to be car.start is start. Car.end is end. New left.left is car.left. New right.right is current.right. Car.left left is new left. Cur.right is new right. Cur.overlap plus equals 1. Okay, I think that's the manipulation we need. This bit gets shuffled down to the left. This bit gets shuffled down to the right. This bit stays where it is. We just have to drag in the ends. That's what this bit is doing. We connect these bits on the left and right. And then what used to be down here gets glued in even further left and even further right. I'm just trying to think. Yeah, no, that's fine, that's fine. Yeah, and then this bit here is now overlapping by one more than it previously was, so that gets incremented. Whew. Okay. Overlap is overlap break. Whew. I think that was the easy case. God. Shall we do the sort of inverse, where the new completely contains the old? So I think all we want to do here is do a... What do we want to do? This bit here might influence the left child, and this bit here might influence the right child. So what we want to do is basically say cur.start. No, the current doesn't change, does it? It's apart from plus equals 1. And then I want to basically do self.book going from start to current.start. Overlap on the left is that. Overlap on the right. Oops, I'm spelling this badly. I want to do a self.book with current.end to end. So then this just gets dealt with on each side. And then I want to do overlap is the max of current.overlap. Overlap on the left, overlap on the right. Break. Okay, maybe that was the easy case. Because we didn't actually have to change this. We might have to change his children, but I think that's okay. Maybe this would be better recursive. Anyway, we've started this way. We'll carry on this way, at least until I get horribly stuck. If it only overlaps on the left, then this, well, everything changes really, doesn't it? It's going to be current.end is actually going to be end, and current.overlap is going to increment by 1. There's some stuff hanging around over here to the right of this node, we can just shunt it along a wee bit. New right is an interval node starting at current dot. Oh, I don't want to do that yet, do I? Let me change the order of these things. It's going from the current. Oh, sorry, no, it's not going from the current end. Oops. It's just going from the end of the interval we were given through to current dot end, with an overlap of, what is that overlap going to be? It must be an overlap of 1, mustn't it? Yes, because this has some, this side all has some known overlap, but this side does not yet. On this side, we want to say new right dot right is equal to current dot right. Current dot right is new right. Current dot end is now end. Current dot overlap plus equals 1. Then I want to do a overlap left is self dot book going from the start to the current dot left. I'm just starting to worry about my signs here. If the end of the interval, I think that might need to be less than or equal. Anywho, what we want to do here is now say overlap is equal to the max current overlap, and the overlap left, break, and then it should be perfectly symmetric on this side. So we've got a new left, which is this thing here. Ooh, hang on. No, the new right doesn't. It actually just keeps current dot overlap. So yeah, this bit all had some overlap. Whoops, that was a problem. IV node goes from the new left is this chunk here. It goes from current dot start through to start with current dot overlap. New left dot left is current dot left. Current dot left is new left. Current dot start is start. Current dot overlap plus equals 1. That's that bit. And then now there's this chunk here. What we need to do is do an overlap right is self dot book going from the current dot end through to the end. Overlap is max of current dot overlap and overlap on the right. Break. Whew. Okay. Nasty, but I think it works. This should probably all be refactored out into a recursive method, but I can't be bothered. For now, anyway. So let's see. Does this even run? How many typos have I got? Current is not defined. I knew I was going to do that mistake. This is on line 62. Let's see how many times I've made that mistake. I think I used overlap more, so it's quicker to make that change. N should be an integer. Have I accidentally reassigned end somewhere? And current.start should absolutely be a node as well. Oh, that's where I've made a mistake. Line 59. That should go from there to there. This is why strong typing can be useful. Hey, that actually worked, my god. I wasn't entirely convinced it would. So, we've only got one test case, and the format to input test case looks a bit gross, so let's submit it and see what happens. Testing in production, gotta love it. Very noisy motorbike, but oh my god, we actually did it. Haha! I'm actually absolutely chuffed with myself. I struggle a lot with Leetcode hard problems because they're often a case of, have you seen the trick? I saw the trick. I'm so happy. I assume this kind of data structure actually exists. I don't know what it is. I've never actually seen this kind of data structure in the wild, but I guess it's probably something like an interval tree or a range tree or something. I don't know. I'll have to do some Googling afterwards and see what I can find. But that's it from me today. That's it from me this week, I believe. Thank you very much for watching. Do remember to like, comment, subscribe, all of that good stuff. If you've got any comments on what you'd like me to do, it doesn't have to be Leetcode, or it could be a specific problem, or it could be anything you like. Just do let me know. I'm keen to branch out a bit on this channel. But that's it from me. I will see you next time. Have a great weekend.